Okay, the question is, if 20 ml of 0.1 molar BaNO3 barium nitrate are added to the 50 ml of 0.1 molar sodium carbonate, will barium carbonate precipitate? And we are given Ksp of barium carbonate 8.1 exponent negative 9. Okay, how to answer this question? First, we have to know that this is barium nitrate. So this is barium nitrate. The volume is 20 ml. Concentration is 0.1 molar. And then this barium nitrate will dissociate to form Ba2 plus NO3 minus 2. The most important thing is we want to know what is the concentration of Ba2 plus, because we want to know the barium carbonate. Okay, so the concentration is 0.1. That means concentration of Ba2 plus also 0.1 molar. Alright, and then this one 50 ml of 0.1 molar sodium carbonate. So the solution is like this. The concentration also 0.1 molar, and the volume is 50 ml. And here sodium carbonate Na2CO3 will dissociate to form 2Na plus and CO3 minus. The concentration is 0.1 molar, and we want to know the concentration of CO3 minus, because this is dissociation 100% and the stoichiometric coefficient 1 in 1. So the concentration of carbonate ion is also 0.10 molar. Okay, we want to know this ion, barium ion and carbonate ion. And when we add these two solution, okay, it's become like this. The solution now become 20 plus 50, 70 ml. Okay, and what happened to the concentration of, and in this solution we have 4 ions. Okay, we have A2 plus, CO3 minus, Na plus, and NO3 minus. Okay, we have all these kind of ions, but the most important is barium ion and carbonate ion. Will this ion react and form precipitate? This is what we want to know. Okay, so we have to know the new concentration of barium ion and carbonate ion, because before addition the volume of barium ion is 20. Now when it's mixed, it's become 70 ml. That means the concentration must be different, because looks like this is a dilution because the volume is increased. The same thing goes to carbonate ion, from 50 ml to 70 ml. Okay, so we have to calculate the new concentration of Da2 plus and CO3 minus. Alright, so now the equation is like this. We take this barium carbonate, BaCO3 solid. Now this one will dissociate partially. Okay, because this salt has Ksp, Ba2 plus, aqueous, and CO3 minus aqueous, right? And now the concentration now is different, because of when the two solution mix, the solutions become more, so we can use this formula for Ba2 plus M1V1 M2V2 equal to M2V2. This is molarity of the new one. The volume is 70 mil. Okay, 20 plus 50 becomes 70. And here M2 is the concentration of Ba2 plus before they mix, and the volume is 20. So now we know the new concentration 0.0285 molar. This is the new concentration of barium ion, and then we calculate the new concentration of carbonate. We use the same formula, M1V1 M2V2. This is formula for dilution. Alright, this is also 70. Okay, concentration of CO3 to minus 0.1, and this one is 0.1 and 50 mil. Okay, now the carbon ion is 0.0714 molar. Okay, and then from this equation we know that we can use this formula Q. We call it QSP. This is not KSP but QSP because this is not at equilibrium yet. We don't know whether this concentration is at equilibrium or not, so we use QSP, but the formula is the same, concentration of Ba2 plus times concentration of carbonate ion. Okay, we use this formula, and then we will substitute this concentration to this equation. So okay, 0.028. So I can QSP, concentration of Ba2 plus CO3 to minus, and then Ba2 plus is 0.0285, and carbon ion is 0.0714. Now 2.039 exponent -3. Okay, if we look at this value compared to this value KSP, it's clear that QSP greater than KSP. That means the solution now is super saturated. Okay, the solution is super saturated, so some of barium carbonate will precipitate. Okay, this is the answer, because the QSP greater than KSP and the solution is super saturated, and some of barium carbonate will precipitate. Okay.